Today we're announcing the SPCS Ingress Gateway, which gives sophisticated customers the ability to manage the HTTP traffic going into their services, all while staying within Snowflake's secure governed environment and without the need for any third-party tools. The gateway supports three main classes of scenarios, as well as underpinning some of Snowflake's machine learning capabilities. The first scenario is support for stage rollouts and A/B tests. It also gives customers the ability to have long-lived URLs that exceed the lifetime of individual services. This feature also enables customers to set up highly available service configurations in which traffic is split among multiple instances in different availability zones of the same region. Let's first cover staged rollouts and A/B tests, which are common approaches used by sophisticated customers as part of their DevOps pipelines. What I have here is two services, the alpha and the beta version. And let's say the beta version has my latest code changes that I want to safely roll out, while making sure that I can also roll back if I encounter any issues. Services today have their regular Ingress URLs. So if you go into the endpoint that I expose, you can see the Ingress URL of the alpha and the beta service. And what the gateway will enable us to do is provide a single URL that splits the traffic between these two services. So let's go ahead and set that up. The first step I'll do here is I'll create a gateway object. And as you can see in the specification here, I'm declaring that this is a traffic split gateway. And then I'm defining a 50-50 split between the alpha version and the beta version of the service. I'll go ahead and execute that statement, and that will create the gateway. Now I can go ahead and describe the gateway, and that's where I will obtain the new Ingress URL I'm going to be able to use that now sits in front of my two services and does the traffic split. So let's wait for that to update. We can now copy the Ingress URL, and I've set up a small load test over here which will fire off 500 requests to the gateway URL, and then we can see how the traffic gets split between the two services we've implemented. There you go, the test is complete, and we notice out of 500 requests, we have 270 going to the alpha backend, 230 going to the beta. So roughly adheres to the 50-50 split we defined. And this is obviously not fully deterministic. If we rerun the test, we get much closer to that 50-50 split. So now, in an actual stage rollout situation, eventually we'll want to adjust the traffic split to fully direct the traffic to the beta service and fully shut down the alpha service. So going back to our gateway here, let's go ahead and change the alpha traffic to 0% and then the beta to 100. We're going to reconfigure the gateway. And then within a few seconds, we should be able to rerun our load test and see the traffic now being split according to that new ratio. There we go. All the traffic went to the beta version, and we can now decommission the alpha version. Let's take a look at the second scenario where the Ingress gateway really shines, which is long-lived service URLs. By default, the Ingress URL associated with a specific service has a lifetime that's tied to the lifetime of the service, meaning if you need to drop and recreate the service, you will lose this Ingress URL and not be able to get it back. In most cases, you should be able to change the service without the need to drop and recreate, but there are certain operations such as switching to a different compute pool or changing ownership that would require a drop and recreate. For example, in this service, I'm using a compute pool with extra small instances, which was very convenient during development. But let's say I'm ready to now go to production, or my requirements have changed and I've discovered that I need to use a different compute pool. I don't want to upgrade my entire compute pool to use larger nodes. I want to move this to a separate compute pool that's dedicated to production instances. In this case, I could have set this up in a much more sustainable way, starting with the Ingress gateway, where I could have put a gateway in front of the service and made that URL available broadly to my organization, which then lets me change the service that the gateway is associated with. Let's show how this works with an example. Let's say I've decided I want to move this service to a compute pool that supports GPUs because that's now a new requirement that I've discovered during development. So I'm going to start with creating a new gateway with a single endpoint that's pointing to our original instance of the service, instance underscore alpha, and we're giving it 100% of the weight, meaning all of the traffic will be sent to that endpoint. And then let's get the gateway ingress URL. That'll just take a moment. And test out the service. Okay, we see that the gateway is now pointing to the alpha instance, the original instance. So let's say we've recreated this service in a different compute pool, but want to maintain the same URL. So I already have the new instance here. It's called instance alpha GPU in a GPU compute pool. So let's go ahead and modify the gateway to point to that new service. Go ahead and make the update. Okay. And now within a few seconds, we should see the same ingress URL, this time pointing to the gateway, switching over to our new service instance in the GPU pool. And there you go. Now we see the responses coming from the other service instance, all while maintaining the same URL and without any interruption of service for our customers. Our last scenario is setting up highly available service configurations where services can be made resilient against availability zone failures within the same cloud region. Let's take a look. You'll notice again I have two instances of the same service, and the key thing here is that they're deployed to two different compute pools. Now, we need to make sure that these compute pools do not end up in the same availability zone. And we do that with a concept called placement groups. So let's take a look. So we'll describe the compute pool and we'll look for the placement group, and we'll see that this one is in placement group C. And the other one is in placement group A, which means that the instances being provisioned in these compute pools are guaranteed to be in separate availability zones within the cloud region. If we set up a service that splits traffic between these two instances, it should be resilient against zonal failure. Let's take a look. We're going to create another gateway here, again splitting the traffic 50-50 between the two services. And let's describe the gateway to get the ingress URL. And that'll take a moment. Now we have the ingress URL. Let's copy that over. And we can rerun the same load test we ran before. Just replacing the URL here. As expected, the traffic split is around 50-50. So now let's see what happens in the case of one of the availability zones going down. To simulate that, we'll go ahead and actually suspend one of the services. Okay, the service is no longer showing as running. Let's go ahead and rerun our stress test. As we rerun the test, we can see that the gateway is starting to load balance the traffic from the failed instance into the remaining healthy instance. And there we go. We see that the traffic has now been rerouted to the other instance. And that was a quick summary of Ingress Gateway. Thank you very much.